In this video we're going to look at how we find the rule using a table of values. Before we start looking at the tables, the first thing we need to know is how does the equation look? What is its form? If you look down the bottom, there's a little blue box, says equation of a line is in the form, and on the right hand side we have an equation with a few numbers missing. We've got y equals a number followed by x plus another number. Now we need to find the two values that go into those boxes. If we can find the two values, then we can form a straight line equation. Well, the box in front of the x, you would have remembered from when we studied algebra earlier, is called the coefficient. Now the coefficient of x actually gives us the gradient. The number on the right hand side box is the constant. That is the term that doesn't have a pronumeral, and that actually gives us the y-intercept, but we'll learn a little bit more about that later. Throughout this topic you'll find that the rule is generally shown as y equals mx plus c. M and c are just the numbers that are inside that box. Alright, well, let's start looking at a table. Step number one, you have a table of results already set out. As you can see on the top row, the x coordinates are consecutive and they're going up by 1. The y coordinates are also consecutive, and this time they're going up by 2. But we have 5 pairs of coordinates that we're going to look at. Well, the very first step in order to find the rule is, once we have the table, is then to look for the y value when x equals 0. Now this is a really important clue. It actually gives us the constant term, that is the y-intercept. So I've looked across the table and I can see that when x equals 0, y equals 5. So I'll put that in the box. Step number 3. Now I want to have a look at see how the numbers are changing. If I look at the x coordinates, I can see that they're all going up by 1. But the y coordinates are going up by 2. This is the clue for the gradient. So I'll put that in the box. Now when we go to write the rule, we have y equals mx plus c. So I'll just write that down. Y equals mx plus c. Well, the m part is the gradient, and therefore that positive 2 goes into that box. The c part is the y-intercept, or the constant. It goes into the second box. And now I have my rule. Y equals 2x plus 5. Alright, so we've got our table of results, and we've got our rule y equals 2x plus 5. Now, that should be enough, but if we want to check and make sure, that rule must work for every pair. So essentially what's happening is y equals 2x plus 5 means that the y value equals twice the x value plus 5. And so you can check. Is the y value 5 twice the x value plus 5? Yes. Is the y value of 7 twice the value of 1 plus 5? Yes, it is. Or if you wish to write it down, we'll try that pair, 2 and 9. Does 9 equal 2 lots of 2 plus 5? Does 9 equal 9? Yes, that is a true statement. Therefore the rule works for 2, 9. Does the rule work for 4, 13? Try again. 13 equals 2 lots of 4 plus 5. 13 equals 8 plus 5. That's a true statement. Alright, so what about if you're given the graph and you have the coordinates on there? Well, first thing I want to do is to look at the graph and see if I can identify the points on the line. In this case they're quite clear. So now I'm going to try and transfer those coordinates into a table of values. So my first point on my graph I'm going to start is on the left hand side. So the first point there is -3, 1. And I go down to the table, the x value was -3, the y value was 1. Then I go along the line, and I get -2, 0. Now continue along the line in the left to right direction. So my next point is -1, -1.
My fourth point, 0, negative 2. And my final point is going to be 1, negative 3. So I've transferred the coordinates into the table, so that's done. And now I can just follow the steps from the previous slides. So the main thing I want to look for now is the value of y when x equals 0. So looking across the x equals points, I can find there's x equals 0. That's the pair that I want to look at. So when x equals 0, y equals negative 2. I'm going to place that down in this little box here. So there, that's done. Now, my next point is to try and find out how the y values are changing. That gives me a clue to the gradient. If I go from 1 to 0, I'm going down by 1. If I continue, each one is consistently going down by 1. That's my gradient. I'm going to place that in this little box here. So I found the coefficient of x. So my final thing is to write the rule. So the equation is going to be y equals the gradient, negative 1x, minus 2, which is the constant. Now I can tidy that up a little bit and say that y equals negative x minus 2.
So here's another one. I want you to try the same thing. I want you to transfer the points into the table. I want you to find when x equals 0. I want you to find out what y is, and then I want you to find the gradient and then the equation. So pause the video here, see how you go. You may wish to go back one step and re-look at the video as I went through those steps. Alright, welcome back. Well, let's look at how you went. So if I was going to transfer those points across, first one I would probably start with, get the pen to work, would be this one here. That is 0, 1. Going along, the next one, 1, 2, 2, 3, 3, 4, 4, 5. So first thing I want to do, transfer the information in the table. That is done. Second thing I want to do is to find out when x equals 0, what does y equal? Well, here it is right here. When x equals 0, y equals 1. That's my constant term. How are these numbers changing down the bottom here? They're going up by 1. So my gradient is 1. So my rule is going to be y equals 1x for the gradient plus 1, which is the constant term. And the better way of writing that would be just y equals x plus 1. In other words, the y value is the x value plus 1 added to it. Well, what about if there's no coordinate given for when x equals 0? So what we had before was we could easily identify the constant term because we looked across the top and we found when x equals 0, the number pops out. In this set of results here, there is no x equals 0. But what we can do is we can work our way backwards. We know that the top numbers are going back by 1. If I keep that going, this number here can be a 1. If I go back 1 further, next number across would be a 0. And I do the same on the bottom. How are these numbers changing? Well, they're going now, if I'm going in this direction, they're going down by 2. So now 5 going down by 2 should be 3, and 3 going down by 2 should be 1. So if I want to find the rule, I now have when x equals 0, the y equals 1. That's my constant term. How are all these numbers changing? They're all going up by 2. So my gradient, my coefficient, equals 2. So my rule is y equals mx plus c. M is the gradient, 2x. C is the constant, 1. So there's the rule. Y equals twice the x value plus 1. So that was the first method. The second method is we can actually do it algebraically. what we do is we look and see what the gradient is. So we can see that this number is going up by 2. So we know that the gradient equals 2. So we know the rule is y equals mx plus c. We know the m is the 2. So we start writing the rule, putting in what little bits of information we have. The next step is we take any point in the table and we substitute it into the rule. So we normally take in numbers that are positive and small. So for example, I would tend to take 2, 5. The y number was a 5. The x number was a 2. So what I've got here is, most of my equation is finished. 5 equals 4 plus c, so therefore c must equal 1. So now I have enough information to finish my rule. So if c equals 1, I can go back up there and put it there. So the rule is y equals 2x plus 1, which is what we found earlier. Well, lastly, let's have a look at what happens when we have a pattern. In this case, we've got a series of triangles made out of matchsticks. And what I wish to do is I wish to work out what the pattern is that's going on with the matchsticks and the triangles. And that way I might be able to write a rule so when I have lots and lots of triangles, I don't have to keep counting. So the very first thing I would do is I would start to fill in my table of values. So I'd start off with 0, 1 triangle, 2 triangles, 3 triangles, 4 triangles. Now, I don't know how many matchsticks I need for 0 triangles. The logical thing is most people think 0 triangles, 0 matchsticks. However, we're looking for patterns, so we'll just leave that for the moment. Now if I have 1 triangle, I need 1, 2, 3 matchsticks. If I have 2 triangles, then I need 1, 2, 3, 4, 5 matchsticks. If I have a series of 3 triangles connected together, then I need 1, 2, 3, 4, 5, 6, 7 matchsticks. So if I had 4 triangles connected together, you should be able to keep the pattern going and you'd be able to say I need 9 matchsticks. Now if you go back a couple of slides, you remember that when we didn't have 0, we can actually use the numbers working backwards. So 9, 7, 5, 3. In theory, if I had 0 triangles, I would still need 1 matchstick. So the rule is going to be y equals mx plus c. C occurs when x equals 1, the y, when x equals 0, the y will equal 1. The numbers are going up by 2, so y equals 2x, because that's the gradient, plus 1, that's the constant. So if I needed 10 triangles in a row, y equals 2 lots of 10 plus 1, I would need 21 matchsticks. So 10 triangles requires 21 matchsticks. Now open up your schedule, look at the questions that you need to do, and when you come to class make sure you have everything required, including your question and including your summary notes. Thank you.